Hello everyone, welcome to our session. I'm Wenchen and this is Daniel. We are from the Spark team in Databricks. So I'm also the manager of Spark 4.0, and today we are very excited to be here to tell you about the new updates in the Spark 4.0 release. Okay, I will start and Daniel will jump in later. Okay, I think most of you have seen this slide in the keynotes. So in Spark 4.0, it's a huge release. So it resolves over 5,000 tickets with the help of around 400 contributors. So there are improvements in many areas, like making SQL better and adding more power to the Python APIs and new streaming APIs, and so on. In this session, we will dive into the 4 key areas of innovation in Apache Spark 4.0. So we will first explore the updates to the infra level of Spark, especially the SparkNet component. And following this, we will discuss the new features for ETL, data science, and data warehouse users. So Spark is a general and unified engine. And we hope these new features are useful to you and can make Spark a better tool for all your use cases about data processing. And I will be taking you through the first 2 parts, and Daniel will jump in and cover the rest. So first up, let's talk about SparkNet. So SparkNet is the most important architecture shift of Spark in the recent years. Let's quickly do a recap of SparkNet. So it's all about making Spark more flexible and stable. So essentially, it decouples the heavy Spark driver from your application code and putting it into its own process. So this makes your application smaller, and also your application will communicate with the Spark driver using a server-client protocol. So one of the really important things we focus on in this release is to ensure the API compatibility between the Java Scala APIs in SparkNet. And we have created short interfaces for the major APIs like data frames, Spark sessions, Column, and whatever stuff for the classes in Spark and classes and Connect. So by doing this, when you compare your application against Spark, now it compares against these short interfaces. So this will ensure that we have 100% API parity between the Connect and the Classic. Unfortunately, Spark has tons of features, right? So, and while we have made huge progress, not every single API is integrated in SparkNet. So, but we have put in a lot of efforts to reaching the feature parity. So we have implemented many basic functions and features, including Spark ML in the SparkNet. And in Spark 4.0, I think we claim that we have reached 99% of the feature in SparkNet, and we are still pushing for it. And we hope we can hit 100% feature parity very soon. And you can also see our tracking work on these 2 tickets. So we knew that getting started with a big architecture change is very painful. It's a very big change that you have to redeploy your Spark applications with a different architecture. So in Spark 4.0, we make it easier by adding this new flag, spark.api.mode. So this will let you turn on SparkNet without deploying a server beforehand. So when you run your application with this config set to connect, so Spark will launch a dedicated Spark Connect server for your application, and they will communicate with a secure local connection. So it won't give you all the benefits of SparkNet because now you have a dedicated server for your client. There is no sharing clients for the server, but it's a good start. So it can help you to prepare your application to be compatible with SparkNet, which will be more robust, more support of languages, and more stable. So to make the onboarding process even more simpler, so Spark 4.0 also brings 2 more PySpark packages in the pipeline. So first, there is a PySpark-Connect package. So this package is just the 4 PySpark with Spark Connect turned on by default, which means the API mode I just mentioned will be set to connect in this package. And it also includes all the necessary dependencies that are required by the Spark, like the gRPC, like the arrow dependency. They are all in this package, so you can use Spark Connect out of the box, very simple. And if you already have set up a Spark Java server ahead, like by your admin or someone else in your company, so you can also use the PySpark-client package. It's a thin client. It's only 1.5 megabytes, so it will be a much lightweight solution for your application. Last but not least, the multi-language support. So we actually mentioned last year that this new server client architecture makes it much easier to implement new language support for Spark. And we are happy to tell you that we have delivered on this. So in Spark 4.0, first, the building support, we have support Python, Java, and Scala out of box in Spark. And also, the Spark community maintains 2 official sub-projects for the Go and Swift clients. And also in third party, there are clients for Rust, .NET, and R. And also there's the good news that the author of the Rust client is contributing this to Apache Spark. So it will also becomes first party very soon. The next feature I want to talk about is the struct logging. So if you have addressed any logs in Spark before, you know that it's very painful because it's just text log in log4j, right? So they are unstructured, and it's very hard to find some meaningful data from the text logs. Starting with Spark 4.0, so logs can be in JSON format. So this feature makes it easier to consume the logs and find the information you want. And all you need to do is to turn on this flag, spark.log.structures.log.enabled, and then you just run Spark applications and catalog files, which are just in JSON format. So with JSON format, Spark can read it natively, right? So now you can use Spark to read your JSON logs and run queries in either different or SQL or whatever language you want to see the insights from the logs and debug your application. You can also check out the full release notes of Spark 4.0 to find any other changes that we made to the infra level. And let me also highlight something here. So first, that in the 4.0 release, we dropped the Java 8 support, which is kind of support by the official. And we also support Java 17 by default. And we also dropped the Scala 2.12 support and make the 2.13 the default. And also we provide the experiment support for Java 21. So you can now run and deploy your Spark application with Java 21. And also we added a new native Spark Kubernetes operator, so which makes it easier to run your Spark application on Kubernetes. And also we dropped the Python 3.8 support, which is also end of life, and there are many other features. Now let's move to the next section, and let's talk about the new features for ETL users. The first thing I'm happy to announce is a new variant data type. So for ETL, it's common that you have to deal with semi-structured data like JSONs. So which they don't have a static schema. So maybe every row has different schema, and you don't know how to turn it into a table, right? So a very common solution people have with Spark is to turn the data into JSON format and save it as a string column in some table. And then when you want to query it, just read a string and use the Spark functions like pass from JSON and whatever get field to pass the JSON on the fly and get the fields you want. So this is very inefficient because as you can imagine, you have to pass a bunch of JSON string only to get a very tiny bit of data you want. So in Spark 4.0, we solved this problem with the new variant data type. So it's as visible as JSON that you can have dynamic schema for every record, and it's also an open standard in Parquet, but it's much faster than JSON. So let's see an example. So let's see that the variant type was formed from some JSON string that you pass using the pass.json function in Spark SQL. But it's a standard, open standard, so you can also use other APIs from the third party to build your own variant values. So after you have the variant value in Spark, you can now use the variant get function to get the field you want out from the variant data. So this function requires you give a JSON path syntax, which is also an open standard in the JSON world. So to specify which field you want to read. And then you specify the type you want the field is, because we don't know what the type is. It's a dynamic. So in this example, we want to get the field user agent and its string type. So then this function will return a string value to Spark SQL, and now you can use all the functions you want to deal with the value to continue your application. So our benchmark shows that there is 8 times speed up for a simple workload using the variant compared to using JSON as string to pass the string and get the field. Okay, next, let's talk about the connectors. So when it comes to ETL, the very first step is to loading the data, right? So, and that's where the Spark shines, because Spark has a rich set of connectors out of the world, right? There are so many third-party libraries and plugins to provide you the solution to access the external data. So in Spark 4.0, we added the built-in support of XML. So now you can use Spark to read XML files out of box. So there's no other plugin needed. Just use .xml and put the path, and the data is here. In addition, so this XML data source was contributed from a third-party project, but it's not just a single port. So we rewrote almost every line of code in this third-party project to make sure that it has the feature parity with the built-in data source in Spark, like the JSON and the CSV. So they have support partition colors and some options. They have feature parity and with the same performance. We also added the from XML to XML functions for you to just deal with some strings in XML format. Another exciting feature that is the Python data API. So we designed this to be easy to implement. In fact, you can just use AI to generate the Python data for you, which is much simpler than you're writing the Scala code or Java code to implement a traditional data v1 or v2 implementation. And thanks to PyPy, it's also very simple to publish and share your data with others. Just publish your data to PyPy and tell us the repo name, and people can just download it with PyPy install and use it in their applications. So essentially, it's just like a simpler version of Data v2 in Spark, and which means that we hope to have more people to contribute to this data source ecosystem, and they can use their favorite Python language to implement, and also make the data loading step much easier than in Spark by these third-party data sources. And Daniel will also cover more details of this in the session later, so stay tuned. So for powerful and complicated data sources, so Data v2 is still the API to use. And we also have many improvements in Data v2 in this 4.0 release. So let's name some. So we support the clustering mechanism in the Spark Data v2, which is already implemented in the data lake. And we also want to have this in Aspect as well. And we also add the API for store procedure, so which can help you to invoke some procedure code to do some work. And we also improve some performance feature like storage partition join and many others. Okay, now the last topic I want to dive into is the streaming. So in the real world, the data keeps growing, right? So the engine must keep up. So we need to process the data incrementally. And in other words, we need the ability to do streaming queries. So when we talk about streaming queries, one of the most important things is the streaming state. So because when the things go wrong in your query, you have to restart, and we don't want to reprocess all the data, right? Which can be like years data from the old time, so it's too expensive. So we need to have some state to remember where were we when we processing the streaming data incrementally. So, however, if there's something wrong with your streaming state, like some corruption or some like bugs in Spark, so it's very hard to debug, and it will also will stop your application from restart from some checkpoint. So in 4.0, we provided 2 data sources to allow you to look into this streaming state and debug for your application. So now you can use state-metadata data source to look at the high level of your streaming state, so which like the operator ID, number of partitions, and so on. And there's another one called state storm, so which provides more low-level information, like the partition ID and the low JSON string of your state. Another powerful feature is the new transform with state API in the Star streaming. So this unblocks advanced state management and event processing and timers and schema evolution for user-defined streaming processing logic. So for more details, you can also read this Databricks blog post that we published a while ago. Okay, now I hand over to my colleague, Daniel, for the 2+.
Hello, my name is Daniel, and I work on Apache Spark at Databricks as well. And I can cover the second 2 sections of the Spark 4.0 talk, so thanks for coming. Cool, so next section, we can cover data science features, and then after that, we'll cover data warehouse features. It's kind of like the way we decided to split the new features apart. There's a lot of stuff in Spark 4. There's a lot of new stuff, so I'll try to go through this and give each new feature the justice it deserves. There's just a lot of stuff, so try to get through it all, okay? So yeah, start off PySpark native plotting. This is kind of fun. So now you can take any PySpark data frame and just call .plot on it, and it'll use the Plotly library to generate charts for you. So this is just really integrated and built in. So this is nice for iterating if you're trying to use the PySpark data frames and you want to see what the data is. You can just iterate and crank out plots with it. There's a lot of stuff you can do with that. For example, pie charts, you just get a quick visualization of the disposition of the values in your data frame. Right, so it uses Plotly, and you call different methods on the data frame, and it'll do what you tell it to do. Right, so here's kind of like a list of the different plot types that it supports. There's a lot. My personal favorites are the pie chart and probably histograms, but that's just me, one person. There's a lot more of them, so if you've used Plotly, these will be familiar to you. Otherwise, it's really easy to kind of get into it. Right, so here's an example of a scatter plot. You can call df.plot.scatter and then give a bunch of parameters to it. So on the upper left of this slide, there's kind of like the df.show rendering of the data, and then to kind of compare it with what a scatter plot might look like. So this is one example of things you can do. Cool, and then this is a pie chart. This is probably my favorite rendering because it's just super easy for people to understand if you show them a pie chart breakdown of something. You have all the categories in a list, and then you have the pie chart. So it's just like a lot easier for some people to consume than a table. And it's really easy to generate one, as you can see in this example. Cool. All right, so next big feature, Python UDTFs. I'm personally excited about this one. I personally helped contribute on this one. This is pretty powerful. Yeah, so the idea is that you can define a UDF in Python that you can call in the from clause of your SQL query or invoke as a data frame to get a relation, right? So it generates a table as an output instead of a single value. Yeah, so this is kind of an example of, a brief example of how to define one, right? Like you define a class, say what the return types of the schema columns are, and then make this eval method that gives you the data, and it basically yields rows. Right, so this is kind of like zoomed in, like picture of what a basic implementation looks like. So it's easy to get started. So this is an example of what it might look like to call one, right? So you can select from the UDTF generating a table. Here we pass 2 scalar arguments. We use SQL named arguments for this just because it's kind of a nice feature that is now available in Spark and Spark SQL, and it's kind of similar to the Python like passing named arguments feature. And then here's how you might invoke the UDTF with the data frame API. So this is kind of like the intro. So, okay, so these are kind of basic use cases, and it's like, okay, this is kind of cool, but why do I care? So there's a lot of advanced features if you dig into the API, right? So, for example, you can actually define, instead of the schema of the UDTF being a static table with static names and types of columns, you can programmatically define it, right? So you define this analyze method that takes the argument values of the function call, right? So you can inspect the actual literals or values or whatever, and then use them to make decisions, and then generate a schema and metadata for that particular call. Right? So for this example, you could take a file name, look at the string, open it up, see what's inside, and then depending on what's inside, you give it a table that comes out. So that's very reusable. So for example, you might call it like this, give it a file name, open it up, oh, there's 2 values inside. So that's one thing you can do. Right, so what else can you do? These user-defined table functions can take scalar arguments, but they can also take tables as input, or one table as input, right? So, and to do that, you can pass the table as an argument with this table keyword in SQL, table parenthesis t, or name of the table, or you can pass a table subquery, and that will give the input rows of the table to the Python TVF as an iterator. You can iterate through them. And when you do that, in the function call, you can specify a partitioning of the rows and an ordering within each partition, which means that for every unique combination of values of these partitioning expressions, the function will get called exactly once, right? So if you see this example, partitioned by ID divided by 10, for every unique value of ID divided by 10, UDTF will get called once and get all of the rows of that partition. And they'll be sorted by ID. So this is useful to kind of split up the work. Right? And then at the end, you can define this terminate method to do something at the end. Right? After you've consumed all these rows of the input, you can do finalization steps at the end, which can also yield additional rows. Right? So for this example, you init the class when it gets created. And this eval method gets called once for every row, and you can inspect the row. It's a Apache Spark row object, which already exists, and then you can look at the values, update internal state, possibly yield rows or not, and then in terminate method, you could do any finalization steps. Cool. So yeah, they can take scalar arguments or tables as input, define the output schema dynamically. For each of these methods, you can also make them accept variable arguments, right? So you can say star args or star kw args, like Python will let you do. And you just define it like this, and then the function will accept variable arguments, and you can just inspect them, right? So if you say it accepts star kw args, whatever you call the function with, it'll work, and then the methods can look at what the arguments are, right? The names of them, and then the values. Right, so you can make a UDTF like this, just pass in some values, and then do what you need to do. Cool. And then finally, within this custom analysis, polymorphic analysis, where you define the schema of the function call for the provided arguments, you can also put other metadata in there, right? So you can subclass this thing, and in this expensive initialization that you do, right, opening a file or connecting to some API, making REST API calls somewhere, doing whatever you need to do, you can put all that state into a subclass of this analyze result, and that'll get passed around to all of your eval methods, or your instantiations of the Python class. So you don't have to do that again, right? You can just like save the work So if you want to do expensive stuff once, you can just do it then and then pass the results. This is kind of what it looks like, right? Your analyze method can take arguments, look at them, say, okay, I have certain things to do, figure out the schema, and then return this subclass with a schema in it for that call, and then some other data, metadata in there. All that will get passed into the eval method. Cool. So that's Python user-defined table functions. Give it a shot. Okay, next thing, Python data sources. As Wenchen mentioned, this is new. Why is it awesome? Because people like Python, not just me, other people. It's really easy to use to get started with. Even AI bots can use it, right? So this is kind of like the base class. And you can use these things to define read access to data. You can also write to them, so you can do DML operations into the data source. Right, so the idea is you define one with this class, register it in the current Spark session, which is kind of very similar to registering like a PySpark UDF, right? And then go have at it with a spark.read, and you can just say .format equals my data source, and then load the data out. Or you can do df.write into it as well. And all of the data that you write will get propagated into the API, so you can do what you need to do. This is pretty easy to use. So you can ask ChatGPT or your favorite AI to make me a PySpark data source doing X. It especially works well with APIs. So you say, here's a REST API. Make me a data source based on this, and it generally will work. So that's pretty cool. Okay, next feature, PySpark UDF profiling. So this is kind of in response to people using PySpark UDFs over several years, right? So, and a big feedback from the community was, what's going on with my Python? I'm doing expensive stuff, and now it's AI time, like AI era, and they're doing even more expensive stuff. What's my Python doing? I want to figure it out. So this is kind of one answer to that, right? So you can kind of track the behavior in both performance and memory usage. Right? So to enable it, you set these configs, and then you can say spark.profile, collect performance or memory, and then dump it to somewhere. So this is kind of like an example of what it looks like, right? You define your PySpark UDF, do stuff, and then set the profiler config. And when you show it, you get an output that might look like this, right? So here are all your different elements in the performance profile, and you can kind of look at what happened and how long it took. So that's kind of one useful feature you can do to debug where the time is going. Right, and by the same token, you can do the same thing with memory use. So you just use the PySpark UDF profiler with the memory profiler, and then print it out, and then you'll kind of see where the memory went and broken down by components, right? So Python can eat up memory, even just importing libraries. Find like, where did my several hundred megabytes go? It's gone. Python ate it up. So now you can ask, where did it go? Cool, okay. It's kind of next thing for debugging, debuggability, right? So you can have a error conditions, error contexts, right? So if your program fails or something happens, a big feedback from folks using Spark was that the error messages got a little confusing. There's kind of like not a lot of consistency among different types of exceptions, and some of them were pretty vague and stuff. So we kind of went through them all and like categorized them up. So yeah, so now they have these nice categories that are all documented. You can look at this list to kind of see. You can Google around if you get one of these, and it's like the key, the condition serves as a nice key. People can kind of look at the docs or like discuss it. Right. So now, as a result, when you run into a problem, you can get kind of like a nice code and then the description. I think the code can be a link. You can click on that. It'll take you somewhere useful. Right? So this is kind of like a nice illustration of what division by 0 looks like now versus what it used to look like. Right? You used to get this like Apache Spark internal esoterica before, and the actual important stuff was like in there somewhere deep, and now it's kind of categorized by importance, right? So they have the code, concise description of the error, and then we have the SQL state, which is like canonical way to describe the category of error. Right, and then last Python thing, there's a pandas 2 is now part of Spark, right? So there's lots of new features, lots of new stuff. Pandas is awesome. It's a really nice API, so you can use it. You can kind of, if you have small data, you can just use pandas directly, or you can kind of go distributed if you need more power, and regular pandas will kind of not work anymore. Cool. So that's the data science part. Now we can go into the data warehouse part. And there's a lot of SQL features in here. I'll have to kind of speed through them a little bit faster than I might have otherwise wanted to, because they're all so awesome, but we only have limited time. Yeah, so SQL scripting is now in Apache Spark, right? This is a big deal, right? So this means you can do procedural Turing-complete logic in SQL in a program without dropping into Python or Scala, right? So you can do if conditionals, you can do loops, you can do exception handling and throw exceptions. You can even call execute immediate, generate a string of SQL, and then call execute immediate and run it, kind of like Python's eval. So there's a lot of powerful stuff you can do. Right, so it starts to look like this. And this is SQL PSM, so this isn't the standard, right? So this is not just something we made up arbitrarily. This is like very standards compliant. Right, so you can get pretty deep with this stuff, right? So you can declare variables, you can do loops, then you can assemble up strings like this alter query example, and then call execute immediate to run them. Right, so you can do all this stuff. If you prefer SQL, or your organization has analysts that are really deep into SQL and that's what they want to do, and they do not want to use Python, now there's an option for that, right? Cool. So SQL scripting is a big deal, okay. Next thing, SQL UDFs. They've been in Databricks for a while, so now they've been properly kind of ported and integrated into Apache Spark. So this means you can take your logic in SQL and package it up into UDFs that take arguments and return values. These can be scalars or tables, and they support named arguments for the function calls, right? So there's kind of a lot of consistency with this feature and other kind of SQL engines. A lot of SQL engines have this. It works a pretty similar way, right? So here's an example of what you can do. You can create the function, apply defaults on the arguments. You can apply comments on them. You can have this you can have an optional returns clause that says the return type, or you can skip it and then put the content of the function. And when you call this thing, Catalyst will just inline the body of the function at the call site. So it's very, very fast. It doesn't like invoke any kind of serialization or virtual machines or anything. It'll just run the SQL you tell it to. Right, and you can do this with tables as well, so it can return a table. It's the SQL TVF here that you can basically make a view and parameterize it. It's like take a view, make it take arguments, right? All right, so you can kind of use it like this. Cool, and when you call these things, you can use named arguments, right? So this kind of makes things easy to use when you have complicated arguments you're passing, right? So that's kind of nice. And they also accept default values, so you can add new arguments to your existing functions and make them defaults. So they don't have to be specified, and you can pass named arguments when calling them. So you can add new optional arguments that you can just put named arguments at the end. So they're very extensible. Cool, okay. All right, so I'll go through pipe syntax briefly because we did cover it on Monday, but I personally did this one. It's based on a paper from Google last year at VLDB. Right, so the idea is, this is regular SQL. The idea is when the logic in SQL gets more complicated than the regular clauses of a query can support, you have to use subqueries to continue, right? So this is TP-CH query 13. And with pipe SQL pipe syntax, you can basically pipe the clauses of SQL in any order. So this is like data frames, right? It's very similar, right? So you can say from customer, from table, then do whatever you want in any order. You can say pipe where, predicate. You can say pipe join, pipe aggregate. And then each one's kind of like independent orthogonal operation you can do. Right, so if this is kind of like what regular SQL looks like and what the clauses ordering is, this is regular SQL. This is pipe syntax, and you can just put them in the order you want. It will do what you tell it to do in the order you tell it to do it, kind of like data frames. And the optimizer can still do its job, right? This is still declarative, right? So you're not suppressing anything that Catalyst wants to do or can do today with regard to predicate push down, column pruning, anything else. Right, so for some examples, if you want to write subqueries, this is another more complicated TP-CH query. With pipe syntax, right, you have to add a nesting level every time you do a table subquery. With pipe syntax, you don't have to do that. You can just keep adding stuff, right? Add pipe operators to it. And it's just a sequence, and your brain can abstract the complexity. Because you don't have to understand every single one. You can say, okay, where am I looking at now? Oh, there's this pipe where sales price is greater than 100. That just takes whatever table came in, relation came in, and filters it. So yeah, a nice property of this is you can take a pipe syntax query, and every prefix of operators is itself a valid query. That's a nice property, right? So to debug this, or kind of see what's going on, you can highlight it in whatever, like editor, like in this Databricks SQL editor, highlight it, run selected, then highlight some more, run that, and then just keep going, and you can see it transform, right? You can start with just from T, and that'll give you the whole table. Then just keep adding more steps, and then see what happens to it. So it has this nice property. Right, and this is backwards compatibility property where you can just jump into it. You can add pipe syntax to the middle of an existing SQL query, or just add new pipes to the end of an existing SQL query, because any valid query can be the input. Cool, okay. Session variables, right, you can now define these and assign values to them. You can use them any number of times. It's limited to the session, so when the session ends, the information is gone, right? So this is kind of what it looks like. Declare and set variables. You can set multiple of them at a time, use them as needed, and when the session is done, they're just automatically kind of cleaned up. All right, so this is kind of another example. Cool. Okay, ANSI mode is now on by default. This has taken several Spark versions to get here, but it's now the default, so this will keep your data consistent and correct, right? So for example, if you do a division by 0 without ANSI mode, you get null, and it may happen in the middle of your 3-hour job, and you just don't know, and that's bad because the data is incorrect. Whereas with Spark 4, with ANSI mode enabled, it will throw an error as per the SQL standard. And in Spark 4.0, the error messages are cleaned up, so it's actually easy to read, and it'll kind of give you the source location of what happened. Cool. There's now string collations in SQL, ANSI SQL, so you can assign collations to columns or operations like group by and order by, right? So this is the default collation. If you sort something, it'll kind of give you this, which might be confusing. If you give it Unicode, it'll sort differently. You can tell it to be case insensitive, which is nice if, for example, if you're migrating from Teradata or other engines that are case insensitive, you can assign a case insensitive collation and kind of keep it consistent, right? Here's another example of that. So you can kind of have accented characters and letters appear kind of next to the regular letters. And finally, execute immediate. As I mentioned, you can assemble these strings any way you want, call execute immediate, and it'll run the string you set as SQL, right? So here's the kind of unified example of that. Cool. Yeah, so that's the Spark 4.0 talk. Yeah, thanks for listening to us. Yeah, I think we have to give up the room, but for the next session. But if you'd like to ask us questions, Wenchen and I can kind of speak with you guys in the hallway if you prefer. So yeah, thanks again.